Deep in the cold darkness beyond Neptune spins a world that should not exist as it does. This is Varuna, a dwarf planet wrapped in 25 separate enigmas that defy every expectation of modern astronomy. By the end of this journey, you will know the profound secrets this distant object holds, secrets that could rewrite the story of our solar system's formation. We will explore why it spins at a breakneck speed, what unknown materials stain its surface, and whether a hidden ocean churns beneath its icy crust. What does it take for a world to hold onto its mysteries for so long? Its rapid spin is the first clue that Varuna is no ordinary world. This distant dwarf planet completes a full rotation in just about 6 hours and 20 minutes. For an object of its size, located in the quiet outskirts of our solar system, that speed is staggering. Imagine a ball of rock and ice nearly the width of Arizona, whirling so fast that its own shape is stretched and distorted. Most large objects in the Kuiper Belt turn at a much more leisurely pace, taking dozens of hours or even entire Earth days to complete a single spin. Varuna's frantic dance breaks all the rules. Such velocity typically suggests a violent history. One leading theory points to a cataclysmic impact in the deep past, a collision with another massive body that sent Varuna tumbling end over end, transferring immense rotational energy that it has never shed. Another possibility is that its internal structure is not uniform. Perhaps a dense, rocky core sits within a lighter mantle of ice, an arrangement that would allow it to spin much faster without flying completely apart. This relentless motion creates a world of extremes where the centrifugal force at its equator would be a palpable sensation, subtly flattening the planetoid into an ellipsoid, a stretched-out sphere. Why has it not slowed down over billions of years? The answer may be locked within, a secret to its formation that continues to baffle astronomers and draws us deeper into its story. That dizzying spin is only the beginning of the strangeness. Varuna's very surface presents a riddle written in light and shadow. When astronomers point their most powerful telescopes toward this distant world, they analyze the sunlight reflecting off it, breaking that light into a spectrum, a cosmic fingerprint that reveals its composition. The data tells a clear yet baffling story. Varuna is coated in water ice, but not just any ice. It is remarkably clean and bright, reflecting a surprising amount of sunlight back into the void. This pristine whiteness is the heart of the second mystery. In the harsh environment of the Kuiper Belt, objects are constantly bombarded by cosmic radiation and micrometeorites. This process, called space weathering, should have slowly cooked and darkened Varuna's surface over billions of years, coating it in a dark, sooty layer of complex organic compounds known as tholins. Yet Varuna gleams. It has defiantly resisted this cosmic aging process. So what unknown mechanism is actively cleaning this distant world? One compelling theory suggests that Varuna's rapid rotation could be the key. Its quick spin might cause temperatures to shift dramatically across its surface, potentially triggering a process where ice sublimates, turning directly from a solid into a gas from warmer areas, only to redeposit as a fresh, bright frost in colder regions. This would be a continuous resurfacing event, a slow-motion planetary makeover that erases the stains of space. Another, more profound idea points to internal activity. Could there be just enough residual heat left from its formation, or generated by the gravitational stretching of its odd shape, to drive icy volcanism? Even a faint trickle of material from a slushy interior could repave the surface with new, clean ice, effectively hiding its true age from our prying eyes. The presence of possible complex organics deepens the intrigue. Are these the building blocks of life, buried and preserved beneath that gleaming veneer, waiting for a chance encounter? The debate continues as scientists struggle to explain how a world so small and so far from the sun can maintain such a youthful glow against all odds. That gleaming, pristine surface points to another profound absence, one that makes Varuna an even greater cosmic outlier. Despite its size and icy nature, this world appears to have no atmosphere whatsoever. Astronomers have searched for the telltale signs, watching intently as distant stars pass behind Varuna. If even a thin veil of gas surrounded it, the starlight would dim in a specific, gradual way before the main body of the dwarf planet blocked it completely. Yet observation after observation reveals a starkly different story. The starlight winks out with a sudden, crisp finality. There is no slow fade, no gentle dimming, just the hard, immediate edge of a world standing utterly bare against the darkness of space. This finding places Varuna in stark contrast to its celebrated neighbor, Pluto. Pluto, though similarly distant and cold, boasts a complex, hazy atmosphere of nitrogen, methane, and carbon monoxide that swells and contracts with its seasons. So why does one icy world hold onto a gaseous shroud while another, seemingly comparable one, does not? The answer may lie in a fundamental difference in mass and a tragic history. Pluto is significantly more massive than Varuna. That extra bulk creates a stronger gravitational pull, one just powerful enough to cling to the gases that sublimated from its surface ices over the eons. Varuna, being smaller and lighter, simply lacks the gravitational muscle to hold onto any atmosphere it might have once had. Any gas that attempted to form would have quickly escaped into the void, its molecules easily achieving escape velocity in the weak gravity. Another, more dramatic theory suggests Varuna did have a temporary atmosphere in the distant past, but a colossal impact, perhaps the same one that sent it spinning so frantically, blasted that fragile envelope away forever. Without an atmosphere to redistribute heat, Varuna's surface exists in a state of extreme contrast. The areas facing the sun for a brief moment during its rapid day might become slightly warmer, while the opposite side plunges into the profound, unbroken cold of deep space. This third mystery compounds the others, painting a portrait of a world that is not just active and bright, but also strangely and completely exposed. The absence of an atmosphere is not the only force shaping this lonely world. Its entire journey through the solar system is an exercise in extremes. Varuna follows a path that is not a neat, circular loop but a long, stretched-out ellipse. It travels on an elongated racetrack that brings it as close as 40 times the Earth-Sun distance, only to swing out again to a remote 53 times that vast span. This is not a gentle orbit. It is a lopsided, eccentric journey that takes this dwarf planet on a dramatic tour of the Kuiper Belt's inner and outer fringes over a period of roughly 280 years. Such a pronounced elliptical orbit is a gravitational fingerprint, a clue to a violent past. Stable, circular orbits are the hallmark of a calm and settled solar system, a sign that a world formed in place and has been undisturbed for eons. A stretched path like Varuna's, however, screams of disruption. It suggests that something massive with an immense gravitational pull once reached out and gave this world a powerful shove. The prime suspect in this cosmic mystery is Neptune. In the early days of our solar system, the giant planets are believed to have migrated, shifting their positions in a grand gravitational dance. As Neptune moved outward, its overwhelming gravity could have acted like a slingshot, flinging countless icy objects into these strange, stretched orbits. Varuna may have been one of them, a peaceful world that was suddenly and permanently hurled onto its wild new course by a passing giant. Yet there is an even more tantalizing possibility. What if Neptune was not the only gravitational puppeteer? Some scientists speculate that an unseen, undiscovered planet, a so-called Planet 9 lurking in the far outer darkness, could be responsible for shepherding the orbits of Varuna and other distant objects. This hypothetical world, several times the mass of Earth, could have the gravitational influence to sculpt these eccentric paths over billions of years. Was Varuna's orbit carved by a known giant, or is it being guided by a ghost, a hidden world we have yet to lay our eyes upon? This fourth mystery transforms Varuna from a solitary wanderer into a potential messenger, its crooked path a possible map pointing toward one of the greatest discoveries still waiting to be made in our own cosmic backyard. The pristine white canvas of Varuna's surface is not entirely blank. Scattered across its brilliant ice are mysterious dark patches, some bearing a distinct reddish hue. This is the fifth great enigma. While the rest of the world gleams with unnatural youth, these localized stains suggest a far more complex and active history. They are not spread evenly like a coat of paint, but appear in specific, isolated areas, as if something has recently disrupted the ice to expose a much older, hidden layer beneath. The leading suspect for this discoloration is a class of complex organic molecules called tholins. These are not signs of life itself, but rather the chemical precursors to it, formed when simple compounds like methane are bombarded for eons by solar radiation and cosmic rays. The process is a slow cosmic cooking that turns pristine ices into a dark, reddish, tar-like substance, yet this only deepens the puzzle. If space weathering naturally creates tholins, and Varuna has been exposed to this radiation for billions of years, why is its surface not completely covered in them? The very existence of these concentrated patches implies that the bright, clean ice we see is a brand new layer, and that something has recently caused the older, darker material to well up from below or be exposed from within. Perhaps a recent impact from a smaller object cratered the surface, punching through the young ice and scattering the ancient, dark material across the bright terrain. An even more intriguing possibility is that Varuna possesses a form of geology, however slow and icy. Could there be cryoval cones, not of lava, but of slushy water and ammonia, that occasionally erupt, bringing up deep, tholin-stained material that then freezes in place as a dark blotch against the white? The pattern of these stains is a message, a testament to events that are ongoing. They tell us that Varuna is not a static, fossilized world, but one that might still be changing, still evolving right now. What recent event painted these dark marks upon its face, and what does that tell us about the hidden forces stirring within? Those dark stains on the surface hint at a complex interior, but the sixth mystery lies in figuring out what that interior is even made of. The fundamental measurements of Varuna itself, its size and mass, are locked in a baffling conflict. Determining the properties of a world so far away is an immense challenge. Astronomers have two primary tools. They can estimate its size by observing its brightness and distance, and they can calculate its mass by measuring how its gravity subtly influences any moons or neighboring objects. When these two pieces of data are combined, they reveal the object's density, a critical clue to its internal composition. For Varuna, the numbers do not add up neatly. Some calculations point toward a density so low that it would be less than that of liquid water. A world less dense than water is a profound paradox. It defies the simple logic of a solid ball of rock and ice. Such a finding forces a complete reimagining of Varuna's very structure. One compelling explanation is that Varuna is not a solid chunk but a cosmic rubble pile. Its interior could be incredibly porous, filled with vast networks of empty spaces and caverns between loosely packed boulders of ice and rock. Think of it not as a single stone, but as a collection of countless smaller pieces, all gently held together by their own weak gravity, with more void than mass inside. This would make it a fragile, whisper-light world that could not withstand the forces of its own rapid spin if it were truly solid. Another, even more astonishing possibility is that this low density signals the presence of a vast, hidden ocean trapped deep beneath the icy crust. If Varuna retains enough internal heat from its violent formation or from the slow decay of radioactive elements, it could sustain a layer of liquid water, perhaps mixed with ammonia acting as a powerful antifreeze, separating a rocky core from the outer ice shell. A subsurface ocean would fundamentally alter our understanding of this distant object, transforming it from a frozen fossil into a potentially dynamic world. How can a body so small and so distant from the sun's warmth maintain such a liquid reservoir? The conflicting data on its size and mass is more than a technical discrepancy. It is a direct challenge, forcing us to choose between two incredible realities. Is Varuna a fragile, cavernous wreck, or is it a secret water world holding a hidden sea in the deepest freeze of our solar system? The silence surrounding Varuna is absolute. For years, astronomers have meticulously scanned the space around this tumbling world, searching for the faint, telltale glint of orbiting moons. Their efforts have revealed nothing. This profound emptiness is the seventh mystery. In the bustling community of the Kuiper Belt, having a moon is practically the norm. Pluto has its famous family, Charon, and 4 smaller companions. Haumea has 2 moons. Even smaller, more distant objects are often found with their own tiny satellites. Varuna, however, travels utterly alone. This null result is statistically strange and deeply revealing. The presence of moons is often a relic of cosmic collisions, the leftover debris from a violent impact that became trapped in a gravitational dance. The fact that Varuna has no such companions forces us to question its past. Was its history so uniquely violent that any potential moons were utterly annihilated in the same cataclysm that spun it up to its dizzying speed? Or perhaps its gravitational field, shaped by its odd, elongated form and rapid rotation, is too chaotic and unstable to capture or hold onto any orbiting bodies. Any small moon that ventured too close might have been quickly ejected, flung back into the dark sea of the Kuiper Belt. There is another, more fundamental possibility. Maybe Varuna formed under such unique and quiet conditions that it never experienced the kind of large, moon-forming impact that shaped its neighbors. It could have coalesced from the primordial dust in a particularly sparse region, growing in solitude from the very beginning. This lunar absence is not just an empty observation. It is a loud clue. The lack of moons supports the idea of a singularly disruptive event, a past so turbulent it stripped the world of any companions, leaving it to spin in solitary silence as a monument to some forgotten cosmic violence. What catastrophic story is its loneliness trying to tell us? That brilliant gleam and its dark stains are not the only contradiction on its surface. Varuna's reflectivity itself is a map of strange activity. Astronomers call this property albedo, a measure of how much sunlight a surface bounces back into space. A perfect mirror would have an albedo of 1, while absolute blackness would be 0. Varuna's average albedo is surprisingly high, but the real mystery is its variability. Different parts of the dwarf planet reflect light with different intensities, creating a patchwork of brightness across its tumbling form. Some areas are dazzlingly white, while others are significantly dimmer. This is the 8th great puzzle. Such a stark contrast should not persist on an ancient, inert world. Cosmic radiation and constant micrometeorite bombardment act like a universal sander, slowly but surely darkening every exposed surface in the Kuiper Belt over millions of years. For Varuna to maintain these bright patches, something must be actively repainting them. The most likely artist is a form of frost. The bright regions could be vast fields of fresh, crystalline water ice, or perhaps even frozen volatiles like nitrogen or methane that have recently been deposited. But how does this frost get there? One compelling answer points back to its rapid spin. The dramatic temperature shifts between its brief day and long night could be enough to drive a cycle of sublimation and redeposition. As a slightly warmer region faces the sun, surface ices might turn directly to gas, only to travel a short distance and refreeze as a bright, new frost in a colder, shadowed area. This would be a continuous, planet-wide process of renewal, effectively erasing the dark hand of space weathering before it can take hold. An even more dynamic possibility is cryovolcanism. If Varuna retains a sliver of internal heat, that energy could force a slurry of water, ammonia, and other ices up from its interior to erupt onto the surface. This slush would instantly freeze in the deep cold, creating vast, bright plains of new material that cover the old, darkened terrain. Each bright patch could be the frozen caldera of an icy volcano that erupted 1,000 years ago, or perhaps just last century. The very existence of these variable bright spots screams that Varuna is not a dead world. It is a place where processes are still at work, where its surface is constantly being remade. What hidden engine drives this endless resurfacing, and what does that tell us about the restless energy hidden deep within this small, distant world? The bright and dark patches on Varuna's surface are not just a visual puzzle. They hint at a deeper, more fundamental enigma tied directly to the world's temperature. When scientists turned their infrared telescopes toward this distant dwarf planet, they expected to see a simple, predictable thermal map. A world so far from the sun should have a surface temperature uniformly locked in a deep, unbroken freeze, with only slight variations based on its rotation. The data, however, painted a completely different picture. Varuna's surface is a chaotic mosaic of unexpected hot and cold spots. These thermal anomalies are the ninth great mystery. Some regions are slightly warmer than the surrounding ice, while others are shockingly cold, even for the Kuiper Belt. This cannot be explained by solar heating alone. The sun is little more than a bright star at that distance, and its feeble warmth would create a far more uniform chill across the entire surface. Something else is actively cooking and cooling this world from within. What internal engine could possibly generate such localized heat in this frozen realm? One of the most persistent theories points to the slow, steady heart of a radioactive furnace. Like all planetary bodies, Varuna likely contains trace amounts of radioactive elements such as uranium and thorium, locked within its rocky core. As these elements decay over billions of years, they release a faint, constant trickle of heat. On a small world, this radiogenic decay might be just powerful enough to create subtle warm spots, areas where the internal heat manages to bleed through a thinner or more fractured icy crust. This would be a whisper of warmth from the dwarf planet's very formation, a dying ember from the solar system's birth, but there is another, far more dynamic possibility. Could these thermal anomalies be the signature of a hidden ocean? If a layer of liquid water sloshes beneath the ice, the gravitational tug of the sun, and perhaps even the subtle pull of undiscovered planets, could stretch and flex Varuna's interior. This process, known as tidal heating, generates friction and warmth. The same forces that drive the violent volcanoes on Jupiter's moon Io could, on a much smaller scale, be creating localized hotspots on Varuna, places where the subsurface ocean is closest to the frozen crust. The cold spots are equally telling. They might be areas where the icy shell is exceptionally thick and insulating, or where fresh, bright frost has recently formed, reflecting what little solar energy exists and plunging the local temperature even lower. This uneven thermal map suggests a world that is geologically alive, its internal heat struggling to escape through a fractured and ever-changing shell. Is Varuna a dying ember warmed by its own ancient rocks, or is it a dynamic world churned and heated by a hidden sea? The answer is written in the heat we cannot feel, a temperature map that defies the cold, dark silence of deep space. The warmth seeping from its core and the frost painting its surface point to a violent beginning. But what was the true cataclysm that forged this strange world? This leads us to the 10th mystery, a theory that connects Varuna to one of the most dramatic events in the outer solar system. Astronomers have identified a unique clan of icy objects known as the Haumea family. These are all fragments believed to have been blasted off a larger parent body in a single, colossal impact billions of years ago. The idea is simple and compelling. Perhaps Varuna itself is not a primordial world, but a massive shard from that very same ancient collision. the evidence for this connection seems at first glance quite strong. The members of the Haumea family share remarkably similar orbits, like pieces of the same shattered plate scattered across the sky, and they all possess surfaces of almost pure water ice. Varuna, with its own brilliant water ice crust and an orbit that brushes the edges of this family's territory, looks like a prime candidate for the largest surviving fragment. It could be the core of the destroyed progenitor, or a massive chunk sheared off in the unimaginable violence of that impact. Yet when scientists look closer, the clues begin to contradict each other. The spectral fingerprints do not match perfectly. While Haumea and its confirmed family members show a very specific crystalline structure in their ice, Varuna's ice appears slightly different, telling a subtly altered story of its thermal history. Its orbit, while eccentric, is also not a perfect fit with the tight cluster of the true family members. It is as if Varuna is a distant cousin, related but not a direct sibling, its path through space just a little too different to have originated from the exact same event. This spectral and orbital dissonance has ignited fierce debates. Is Varuna a lost member of this famous family, its path subtly altered over eons by the gentle tug of Neptune's gravity? Or is its resemblance just a cosmic coincidence, the result of a completely separate, equally violent collision that happened to create a world with similar surface properties? The possibility that it is a lone survivor from a different, even larger cataclysm is equally thrilling. This unresolved debate over its lineage forces a profound question. Is Varuna a key to understanding a single, famous impact, or is it the sole representative of a catastrophe we have not yet even discovered, a ghost from a shattered world we never knew existed? The very light that reaches us from Varuna holds its own coded message, and that message is deeply confusing. Astronomers track its brightness over time, plotting a graph known as a light curve. For a uniformly shaped world spinning in a predictable rhythm, this curve should be a clean, repeating wave, a perfect heartbeat of reflected light. Varuna's heartbeat is erratic. Its brightness flickers and shifts in ways that are not perfectly periodic. The changes are complex and unpredictable, forming the 11th great mystery. A simple, ellipsoid shape tumbling through space should create a regular pattern of dimming and brightening as its different faces turn toward Earth. The fact that the pattern is irregular points to a far more bizarre reality. One possibility is that Varuna is not a smooth ellipsoid at all, but a profoundly lumpy and misshapen object. It could be an elongated, almost peanut-shaped body, or one marred by a single, massive impact crater that creates an unexpected dip in brightness whenever it rotates into view. Another explanation points back to the strange surface, the uneven albedo, the patchwork of bright frosts and dark Tholen stains could be the culprit. If these reflective and absorbent patches are not distributed symmetrically, they would create a chaotic light pattern. A vast, dark region swinging into view would cause a sharp dip in brightness, while a brilliant white plane would create a sudden peak, disrupting any clean, repeating rhythm. The most intriguing possibility involves motion itself. Varuna might be precessing, which means its axis of rotation is slowly wobbling like a top about to fall over. This precession would constantly change the geometry of what we see from Earth, altering the light curve in a slow, long-term cycle that overlaps with its rapid daily spin, creating a signal of breathtaking complexity that is nearly impossible to decipher. These unexplained variations are more than a technical problem. They are a direct challenge to our understanding of this world's stability and form. Is Varuna so oddly shaped that it defies simple geometry, or is it actively wobbling on its axis, a sign of internal shifts we can barely comprehend? This faint, uneven warmth could be a ghostly signature of something incredible hidden beneath the ice. The 12th mystery is perhaps the most profound of all, the possibility that Varuna conceals a vast, dark ocean of liquid water. The clues for this are not visible on the surface, but are buried in the confusing calculations of its density. A world less dense than water cannot be a simple, solid ball of rock and ice. One of the most elegant explanations is that its interior is differentiated, with a dense, rocky core surrounded by a thick mantle of water. But this water cannot all be frozen solid. If a significant portion of it were liquid, it would perfectly explain the bafflingly low overall density, creating a world that is part rock, part ice, and part secret sea. The challenge with this theory is as immense as the ocean it proposes. How could liquid water possibly exist in the permanent deep freeze of the Kuiper Belt, where the sun is a mere pinprick of light and surface temperatures hover near absolute zero? The energy required to keep even a sliver of an ocean from freezing solid over billions of years is staggering. One potential heat source is the slow, steady decay of radioactive elements like uranium and potassium locked within its rocky core. This radiogenic warmth is a faint, persistent ember from the solar system's violent birth, a dying fire that might be just enough to maintain a deep, insulated ocean if the icy crust above it is thick enough to act as a blanket. Another, more dynamic source could be tidal heating. Even at this great distance, the subtle but constant gravitational tugs from the Sun and from hypothetical planets like the speculated planet 9 could stretch and flex Varuna's interior. This constant kneading generates internal friction, and friction creates heat. It is the same process that drives the spectacular volcanoes on Jupiter's moon Io, though on a much quieter, more subdued scale on this distant dwarf planet. For a future mission to confirm this hidden ocean, it would not look for water directly. Instead, a spacecraft flying past Varuna would meticulously map its gravitational field, looking for the subtle telltale squishiness that a liquid layer would impose. It would also listen for the faint magnetic signature an ocean might generate as it slowly churns against the dwarf planet's core. Discovering such an ocean would transform Varuna from a frozen relic into one of the most promising places for life in our entire solar system. A dark, abyssal world where the basic ingredients for biology might have been mixing in the warmth for eons. Varuna's hidden seas and erratic spin are not the only forces guiding its path. This lonely wanderer belongs to a special class of objects known as the scattered disk, a population of icy bodies on the very fringe of our solar system. Unlike the more settled residents of the Kuiper Belt, these objects follow wildly eccentric and highly inclined orbits, as if they were flung to the outskirts by some immense gravitational hand. Varuna's own stretched and tilted path fits this description perfectly, yet its orbit holds a peculiar stability that defies the chaos surrounding it. This is the 13th mystery. How has it managed to avoid being completely ejected into interstellar space or sent careening toward the inner solar system over billions of years? The gravitational influence of Neptune is immense, but it may not be the sole architect of this delicate balance. Scientists suspect that a much more distant, far more massive presence could be acting as a shepherd. This hypothetical world, often called Planet 9, is theorized to be several times the mass of Earth and orbiting far beyond Pluto. Its immense gravity could create a stable pocket within the scattered disk, a gravitational refuge where objects like Varuna are trapped in a resonant dance, their chaotic orbits subtly synchronized and stabilized by this unseen giant. Varuna's persistent, predictable path could be a direct result of this hidden interaction, its orbit a single data point in a map that points toward one of the greatest discoveries still waiting to be made. There is another, more solitary possibility. Perhaps Varuna's unique trajectory is not the product of a modern-day shepherd, but a fossilized record of a singular event. It might have received a perfectly calibrated gravitational kick from Neptune during the planet's migration epoch, a push so precise that it settled into this specific, long-lasting orbit without needing further guidance. This would make Varuna a rare survivor, a world that found a stable groove in the cosmic racetrack through a 1 in a million chance. Its continued presence in this gravitational maelstrom is a quiet testament to an unseen order, a hint that even in the most chaotic regions of our solar system, there are patterns we are only beginning to decode. Is its stable orbit the signature of a hidden planet, or simply the echo of a perfectly executed push from a known giant, a fossilized orbit from the solar system's most turbulent era? Methane ice should not last long on a world like Varuna. This simple fact lies at the heart of the 14th Great Mystery. When scientists analyze the light reflecting from its distant surface, the spectral data strongly suggests the presence of frozen methane. Yet methane is a highly volatile substance, an ice that turns directly into gas with astonishing ease under the faint warmth of the distant sun. At Varuna's typical orbital distance, any exposed methane ice should have sublimated away into the void eons ago, vanishing completely. Its continued presence, if confirmed, is a paradox that defies the basic principles of chemistry and physics in the outer solar system. How can this fragile frost possibly persist? One compelling theory proposes a protective blanket. The methane might not be lying bare on the surface, but instead buried beneath a thin, insulating layer of more resilient water ice. Think of it like a layer of snow covering a patch of dry ice. The snow shields the volatile material underneath from direct solar radiation, dramatically slowing its escape into space. This would mean the methane we are detecting is actually leaking out from below, its spectral signature a ghostly whisper from a protected reservoir. Another, far more dynamic idea suggests that Varuna is continuously renewing its supply. Recent cryovolcanic activity or other resurfacing events could be bringing fresh methane from the interior and depositing it onto the surface. In this scenario, we are not seeing ancient methane that has miraculously survived, but rather a brand new coat of frost that was laid down perhaps only a few thousand or even a few hundred years ago. The methane would be like paint on a wall that is constantly being repainted, its presence a direct indicator of ongoing geological life. This leads to a deeper, more profound question. Where did all this methane come from in the first place? Was it captured during Varuna's formation from the primordial solar nebula, locked away in its deep interior for billions of years? Or could it be a product of ongoing chemical processes, manufactured in the dark, warm depths of a potential subsurface ocean? The unconfirmed nature of this methane ice keeps the mystery alive. It is a clue that is both tantalizing and frustrating, pointing toward either a carefully preserved ancient surface or a world that is still actively breathing, exhaling its volatile gases into the freezing dark. This deep freeze might seem permanent, but it raises a 15th and deeply puzzling question. Why does Varuna show no signs of cometary activity? Across the solar system, other icy bodies with similar orbits, like the Centaurs or some distant comets, erupt to life as they swing closer to the sun. Their frozen surfaces warm just enough for volatile ices to sublimate, creating brilliant comas and long, glowing tails of gas and dust. Varuna, however, remains stubbornly inert and dormant. It approaches the sun on its elliptical path and retreats again, a silent, dark traveler without a whisper of a coma or a tail. This profound stillness is a mystery in a region known for its occasional outbursts. One compelling explanation is that Varuna possesses a remarkably thick and resilient crust. This shell of water ice could act as a powerful insulator, sealing in any volatile materials like methane, nitrogen, or carbon monoxide that might lie beneath. The faint solar warmth is simply not enough to penetrate this icy armor and trigger the outgassing we see in more fragile objects. The world is effectively locked in a deep freeze, its potential for activity permanently suppressed by its own geology. Another, more dramatic possibility is that Varuna has already spent its volatile wealth. In its distant past, it might have been far more active, a roaring comet that vented its most easily vaporized ices in a spectacular, long-lost display. That ancient outburst could have stripped it clean, leaving behind only the more stable, refractory water ice that forms its gleaming surface today. It would be a world that has already lived its cometary life, now retired to a silent, frozen old age. Or perhaps the answer lies in its internal structure. If Varuna is indeed a porous rubble pile, those internal caverns could be acting as cold traps, capturing and refreezing any gases that try to escape, preventing them from ever reaching the void of space. This lack of activity makes Varuna an outlier, a world that has chosen a path of quiet endurance over dramatic transformation. Is its silence a sign of a deeply insulated interior, or the mark of a world that has already given up its volatile soul? The profound silence surrounding Varuna might not be as absolute as it first appears. For all our searching, a companion could still be hiding in plain sight, a ghostly partner locked in a dance too subtle for our telescopes to easily see. This is the 16th mystery, the unresolved question of whether Varuna is a solitary world or one half of a secret binary system. The methods used to uncover such a partner are ingenious, relying on gravity and shadow. Scientists meticulously track Varuna's path, looking for the slightest wobble, a telltale hitch in its motion that would betray the gravitational tug of an unseen moon. They also watch for occultation events, moments when Varuna passes in front of a distant star. If a companion were there, it could cause the starlight to flicker in a distinct double-dip pattern just before or after the main event. So far, the results from these painstaking observations have been frustratingly ambiguous. There are hints, faint anomalies in the data that could be interpreted as the signature of a small, dark partner, but nothing conclusive enough to declare a discovery. The potential companion, if it exists, could be too close to the brilliant primary, lost in its glare, or too small and dim to reflect any detectable light. It might even be composed of the same dark, organic material as the mysterious surface patches, making it nearly invisible against the blackness of space. This lingering uncertainty opens up a cascade of new questions. If a binary partner is there, its orbit would reveal Varuna's true mass with exquisite precision, finally resolving the paradox of its confusing density. Its absence, however, is equally meaningful, reinforcing the idea of a uniquely violent past that stripped away any potential companions. The data refuses to give a definitive answer, leaving us to wonder if this lonely wanderer is, in fact, holding hands with a shadow in the dark. The contradiction between Varuna's ancient birth and its youthful face creates the 17th and perhaps most fundamental mystery of all. This world is almost certainly a primordial object, a relic that formed over 4.5 billion years ago from the very same cloud of gas and dust that gave rise to the Sun and all the planets. Its existence in the cold outer darkness marks it as one of the original building blocks of our solar system, a fossil from the very first chapter of cosmic history. Yet, when we look at it, we do not see a fossil. We see a gleaming, active surface that appears by all geological measures to be shockingly young. It is a paradox as stark as finding a perfectly preserved newborn in an ancient tomb. How can something so old look so new? The surface of a world acts as a clock, slowly ticking toward darkness under the relentless rain of radiation and microscopic impact. After billions of years, every object in the Kuiper Belt should be uniformly dark, its ices cooked into a deep, reddish-black crust of complex organics. Varuna's brilliant reflectivity and clean water ice are a clear and defiant violation of this natural aging process. The clock on its surface seems to have been reset, its hands turned back to a time long after its formation. This forces astronomers to confront two radical possibilities. The first is that Varuna possesses a hidden, internal engine capable of constant rejuvenation. This could be the slow churn of a subsurface ocean, driven by radiogenic heat or tidal forces, that regularly breaches the icy shell and repaves the landscape with fresh, bright slush. It could be the planet-wide frost cycle driven by its wild spin, a continuous process of erosion and deposition that endlessly scrubs the surface clean. This would make Varuna a rare, geologically active dwarf planet, a world that has somehow retained the energy to fight off the decay of time itself. The second, more violent possibility is that its youth is an illusion born from a single, recent catastrophe. Perhaps within the last 100 million years, a truly colossal impact shattered its ancient, dark crust. The event would have excavated deep into Varuna's interior, scattering the old, weathered material into space and exposing a vast, virgin layer of pristine ice from below. In this scenario, we are not looking at a continuously active world, but a convalescing one. Its brilliant surface a massive, freshly formed scar that has not yet had time to darken. This single mystery ties all the others together. Its rapid spin, its strange shape, its missing moon, and its puzzling thermal spots could all be the lingering echoes of that apocalyptic collision. Or they could be the symptoms of a persistent internal vitality that has kept this ancient wanderer miraculously young for eons. Is Varuna a survivor of a recent, shattering violence, or is it a truly living world, its ancient heart still beating slowly in the dark? Beyond the familiar signs of water and methane lies a spectral ghost. When astronomers dissect the light bouncing off Varuna, they find faint, stubborn lines in its rainbow signature that refuse to be identified. These are absorption lines, the unique barcodes that every chemical etches into light, and some of Varuna's codes are missing from our cosmic library. They do not correspond to any known water ice, to any familiar rock, or to any simple organic compound we have catalogued from other worlds. This 18th mystery points to the existence of materials we have not yet named, exotic compounds forged in the unique, cold laboratories of the deep Kuiper Belt. One tantalizing possibility is that we are seeing the spectral fingerprints of probiotic molecules. These are the complex chemical cousins to the building blocks of life, substances like amino acids or nucleobases that can form naturally in icy environments under the constant bombardment of cosmic radiation. If such molecules are present on Varuna, their discovery would be monumental. It would suggest that the very ingredients for life are not unique to Earth or even to warm, wet worlds, but can be synthesized and preserved in the most frigid, sun-starved reaches of our solar system. Another explanation could be far simpler, yet just as profound. The unknown lines might signify ices altered by chemistry we do not fully understand. Methane molecules, for instance, could have been radiation baked into long, complex polymer chains, creating a reddish, tar-like substance with a spectral signature unlike anything we have seen before. Or perhaps we are seeing the result of chemistry between water ice and ammonia, forming stable crystalline hydrates that have unique reflective properties. This spectral puzzle forces a humbling realization. Our understanding of cosmic chemistry is based on what we have found nearby on asteroids, comets, and a handful of planets. Varuna is a reminder that the outer solar system is a vast and diverse chemical factory, capable of producing compounds under conditions of cold and pressure that we can scarcely replicate in a lab. What new branch of chemistry is waiting for us on this distant, frozen world? And what could it tell us about the raw materials available when solar systems are born? Its crooked path through the void is a fossilized record of our solar system's most violent era. This 19th mystery connects Varuna directly to the Great Planetary Migration, a time when the giant planets reshuffled their positions in a gravitational upheaval that scarred the entire outer system. According to leading models, Neptune did not form where it orbits today. It was born much closer to the Sun and then slowly drifted outward, its immense gravity scattering countless icy worlds before it. Objects like Varuna were the pawns in this cosmic rearrangement, flung onto stretched and tilted paths as the giant moved. Yet when scientists run these simulations, a curious problem emerges. Varuna does not end up where the models predict it should be. Its specific orbital parameters, its precise combination of distance, eccentricity, and inclination, are a poor fit for the classic migration story. This is more than a minor discrepancy. It is a fundamental challenge to our understanding of how the solar system settled into its current architecture. The simulations suggest that after such a violent migration, objects like Varuna should either have been ejected entirely or herded into much more confined orbital bands. Its continued presence in its particular niche indicates that the migration was either less violent, more structured, or far more complex than we have assumed. One possibility is that Neptune's journey was not a smooth outward drift but a series of fits and starts, with its gravity creating temporary stable pockets that allowed some objects to survive in orbits that now seem improbable. Another, more thrilling idea is that an additional gravitational influence was at work. The hypothetical planet 9, or perhaps even a different, now ejected sibling planet, could have intervened, plucking Varuna from its expected path and placing it on its current, stable course. This single world, with its stubbornly mismatched orbit, forces us to reconsider the entire narrative of our solar system's youth. Was the Great Migration a simpler, gentler process, or was it a chaotic ballet with more dancers than we have accounted for? Varuna is not just a relic, it is a critic, its silent journey a constant challenge to the stories we tell about our own cosmic neighborhood. The numbers themselves seem to be in disagreement. For years, different scientific teams have aimed their most advanced instruments at Varuna, attempting to pin down one of its most fundamental properties, its density, and the results have been anything but consistent. This is the 20th mystery. Some observations suggest a density so incredibly low it would be less than that of water, a finding that implies a world more void than substance. Other measurements using different techniques or refined data point toward a moderately higher density, one more in line with a solid mixture of rock and ice. This wide range of estimates is not a sign of bad science, but rather a testament to the profound difficulty of measuring something so small and so impossibly far away. The methods themselves are ingenious but indirect. One way to estimate density is through thermal observations. By measuring the faint heat radiating from Varuna in infrared light, scientists can infer its size. A larger, warmer object would radiate more heat than a smaller, colder one of the same composition. Combine this thermal size estimate with a mass calculated from its gravitational influence, or lack thereof, and you get one density value. Another method relies purely on visible light, calculating size from brightness and distance. Each technique has its own subtle uncertainties, its own potential for error when dealing with a faint, tumbling speck at the edge of the solar system. The implications of this disagreement are monumental because each possible density tells a completely different story about what Varuna is like on the inside. The very low estimates strongly support the rubble pile model. Imagine a world not of solid ground, but a loose collection of icy boulders and dust, all gently held together by gravity with vast caverns and pores taking up more space than the material itself. This would be a fragile, whisper-light structure that could explain how it spins so fast without tearing itself apart. On the other hand, the moderately high density estimates suggest a more traditional, consolidated world. This Varuna would be a differentiated body with a dense, rocky core settled at its center, surrounded by a thick mantle of solid water ice. There would be no vast internal voids, no secret caverns, just a frozen, solid ball. And then there is the thrilling middle ground. What if the truth lies between these extremes, a density slightly higher than a pure rubble pile, but lower than a solid ball of ice and rock, could be the most compelling evidence yet for a subsurface ocean. In this scenario, a liquid water layer kept from freezing by antifreeze compounds like ammonia would separate a rocky core from an icy shell, creating an overall density that perfectly splits the difference. This unresolved debate means we are looking at a world with multiple identities. Is it a fragile, porous aggregate, a testament to the gentle accretion of the early solar system? Is it a solid, frozen relic, simple and unchanging? Or is it a complex, layered world, a hidden ocean world where the basic ingredients for life might be stirring in the dark? The conflicting numbers are not a problem to be solved. They are a doorway, and behind it lies the true nature of this distant, enigmatic wanderer. The gleam of its surface could be hiding scars of a different kind, features that speak of a world that is not just active but potentially volcanic. This is the 21st mystery, the compelling possibility of recent cryovolcanism on Varuna. Unlike the fiery volcanoes of Earth, these would be icy vents, erupting not with molten rock, but with a frigid slurry of water, ammonia, and methane. On a world so distant and cold, the energy required to melt even a sliver of its interior and push it to the surface is almost unimaginable. So what hidden furnace could possibly power such eruptions? One potential heat source lies deep within its rocky heart. Like the embers of a long cooling fire, radioactive elements such as uranium and thorium continue to decay, releasing a faint, steady trickle of warmth. On a larger world, this heat would be insignificant, but within Varuna's relatively compact frame, it might be just enough to maintain localized pockets of slushy, liquid cryomagma close to the surface. If the icy crust above one of these pockets fractures, perhaps from the stresses of its rapid spin, the pressurized slush could erupt outward, spreading across the landscape like a slow-moving glacier before freezing solid into a bright new plain. An even more dynamic possibility involves gravitational forces. Even at its great distance, the Sun exerts a tiny but constant pull. If Varuna's orbit is subtly influenced by the hypothesized planet 9, the combined gravitational tugs could stretch and flex the dwarf planet's interior. This process, known as tidal heating, generates internal friction. It is the same mechanism that drives the spectacular volcanism on Jupiter's moon Io, and on a smaller, slower scale, it could provide the precise amount of energy needed to liquefy subsurface ices and drive them upward. The evidence for this would be written on the surface in the form of vast, smooth flows that obscure older craters or strange, dome-like structures that resemble frozen lava domes. A single, identifiable cryovolcano would be a smoking gun, proof that this ancient world is not just being resurfaced by frost but rebuilt from the inside out. The existence of such features would force a complete re-evaluation of what small, distant worlds are capable of, suggesting that geological life can persist in the most unexpected places, powered by the faint, relentless ticking of radioactive decay or the silent, rhythmic tug of unseen giants. The very color of this distant world seems to be shifting before our eyes. Observations spanning decades reveal that Varuna is not a static shade of white, but a surface undergoing a subtle, continuous transformation in its redness. Astronomers measure this using a color index, a precise scale that quantifies the hue of reflected sunlight, and the data tells a story of change. The pristine water ice that dominates its surface is slowly, inexorably being tinted with a reddish blush. This color evolution is the 22nd Great Mystery, a sign that the forces acting upon Varuna are more complex and dynamic than we ever imagined. One of the most compelling explanations is a process called impact gardening. The surface is constantly churned by a gentle, cosmic rain of tiny micrometeorites. These impacts, each minuscule on its own, collectively act like a slow-motion plow, stirring the upper layers of ice and exposing fresh material to the relentless barrage of solar and cosmic radiation. This radiation cooks the simple ices, a process known as space weathering that slowly manufactures complex organic compounds called tholins, which possess a distinct reddish-brown color. The rate of this coloring could be variable, influenced by the sun's own activity cycle. During periods of high solar activity, an increased flux of solar wind particles might accelerate the chemical reactions, darkening the surface more quickly. Then there is the tantalizing possibility of seasonal effects. Although Varuna's seasons are centuries long due to its vast orbital period, the slight changes in solar distance as it travels its elliptical path could cause subtle shifts in temperature. A slightly warmer period might trigger the sublimation of fresh, bright frost from certain areas, concentrating the older, redder material and making the overall color appear more pronounced. We are essentially watching a cosmic paint job in ultra-slow motion, a process that reveals Varuna not as a frozen snapshot, but as a world with a changing face. What recent event in its orbital journey has kicked this color shift into a higher gear, and what will this distant wanderer look like in another 100 years? The faint, unseen tug of its gravity tells a story as strange as its brilliant surface. Mapping Varuna's gravitational field is a monumental challenge, a process of watching for the tiniest wobbles in the path of anything that passes near it, or meticulously tracking its own movements for any hitch that might betray an uneven internal pull. The results of these painstaking observations paint a picture of a deeply heterogeneous world, a place where mass is not distributed evenly from core to crust. This gravitational map is not smooth. It is lumpy, suggesting startling concentrations of mass scattered throughout its interior, creating a field of unexpected pulls and pushes. One possible explanation points to the ghosts of ancient impacts. Varuna could be riddled with vast internal voids, enormous caverns left behind when smaller bodies slammed into it and compressed the surrounding material without filling the space. These hollow pockets would create regions of startlingly weak gravity, while the dense, compressed walls around them would act as gravitational anchors. Alternatively, the mass concentrations could be immense chunks of primordial rock, heavy planetary building blocks that never fully sank to the center during its formation. Imagine a fruitcake baked in zero gravity, where dense chunks of fruit are suspended randomly throughout the lighter cake batter, creating an uneven, unpredictable density. This would mean Varuna is not a neatly layered world with a core, mantle, and crust, but a haphazard amalgamation of materials, its interior frozen in the chaotic state of its birth. These gravitational anomalies could even be the reason for its erratic spin and complex light curve, as the uneven distribution of mass tugs and twists on the world as it rotates. What does it mean for a world to be so fundamentally lumpy on the inside? This gravitational fingerprint suggests a history of violent accretion and catastrophic impacts, a past so turbulent that the world never settled into a calm, ordered structure, leaving its deepest secrets frozen in a state of perpetual internal chaos. Our own solar system is not the only one to possess a distant, icy fringe. Across the galaxy, astronomers have observed countless young stars encircled by vast rings of cold dust and debris, structures we call extrasolar debris disks. This 24th mystery asks a humbling question. When we look at those distant disks and then we look at our own Kuiper Belt with objects like Varuna, something does not quite match up. Our collection of outer solar system objects appears to be strangely sparse, almost anemic, compared to the brilliant, dense rings we see around other suns. These far-off disks are often immensely bright with reflected light, suggesting they are packed with a staggering amount of material, perhaps thousands of times more ice and rock than exists in our entire Kuiper Belt today. So where did all of our material go? Why is our solar system's outer frontier, with its lonely wanderers like Varuna, so comparatively quiet and empty? One possibility is that our system formed under uniquely frugal conditions, born from a cloud of gas and dust that was simply less rich in the raw materials needed to build a more populous outer disk. Perhaps we are the cosmic equivalent of a small town, while other stars grew into bustling metropolises in their outer realms. A far more dramatic theory, however, suggests a violent intervention in our solar system's early childhood. What if a rogue star passed uncomfortably close to our infant sun billions of years ago? The gravitational tide from such a stellar flyby would have been catastrophic for our primordial Kuiper Belt. It would have acted like a giant's hand, violently stirring the outer material, flinging the vast majority of these icy worlds into the deep darkness of interstellar space. In this scenario, objects like Varuna are not the norm. They are the rare survivors, the lucky few that manage to cling to their orbits despite the stellar invader's gravitational pull. Their very existence is a testament to a near catastrophe, a ghostly echo of a much denser and richer disk that was almost completely stripped away. Varuna then becomes more than just a local mystery. Its solitary nature and its stretched orbit could be a direct clue to a long-lost galactic event, a silent witness to the day a passing star stole most of our solar system's outer family. The ultimate mystery of Varuna is not one we can solve from Earth, but one that propels us outward. To truly know this world, we must go there. The final enigma is the mission itself, a daring journey to send a robotic explorer across billions of miles for a close encounter. Proposed concepts like a dedicated Varuna orbiter or a high-speed flyby represent humanity's next great step into the dark. Such a spacecraft would not merely take pictures, it would perform a deep and intimate investigation. Its suite of instruments would finally answer the questions that have haunted us for decades. A precise mapping of Varuna's gravitational field would settle the debate over its density once and for all, revealing whether its interior is a porous void, a solid mass, or cradling that hidden ocean. A thermal imager would scan the surface, pinpointing the exact locations of those mysterious hot and cold spots to understand their source. But the most profound revelations could come from a direct sampling of its surface. Imagine a probe, even a simple impactor, kicking up a plume of that pristine ice and dark, reddish material. A sophisticated onboard laboratory could analyze that cloud, identifying the exact nature of the complex organics staining its surface. Are they simple tholins or something more intricate, the complex precursors to life itself? This single act could tell us if the building blocks of biology are common in the frozen reaches of every solar system. The biggest questions are now within our grasp to answer. What is the true engine behind its youthful resurfacing? Does a subsurface ocean, however deep, truly exist? And what can its unique, lumpy composition tell us about the very first moments of our solar system's formation? A mission to Varuna would transform this faint point of light into a world, a place with a story that could redefine our place in the cosmos. Every mystery we have explored culminates in this single, thrilling prospect, a voyage to the edge to meet a wanderer that has guarded its secrets for 4.5 billion years, waiting for us to finally arrive. Varuna stands as a monumental challenge to our cosmic confidence. Its 25 profound mysteries, from the frantic spin that defies gravity to the possibility of a hidden ocean in the deepest freeze, collectively argue that we have only just begun to understand the diversity of worlds. This distant, tumbling object forces us to reconsider everything we thought we knew about formation, geology, and even the potential for life in the cold, dark margins of star systems. It is a world that should not exist as it does, a collection of contradictions that refuses to fit into any neat astronomical box. The very presence of such an enigma so close to home is a thrilling reminder of how much remains undiscovered in our own celestial backyard. So what do you believe lies at the heart of these puzzles? Is Varuna a fragile rubble pile, a secret water world, or something even more extraordinary that we have not yet conceived? Share your own theories about this cosmic outlier in the comments below, and subscribe to continue unraveling the deepest mysteries of the universe with us. The next great discovery is waiting just beyond the light.